In section 2.3, we're talking about quadratics still, but we're going to focus on the vertex of a quadratic and the maximum. So given a profit function, profit is for X items produced and sold. And notice that our profit equation is quadratic because it's got an x squared as the highest power, and it's a negative x squared. So if we were to graph that, as you recall from your college algebra, we would have a parabola that opens down. Okay, here we're going to review from last section. You could take your profit and set it equal to 0. And if you do that, it's called break even. So if I put 0 in for profit and I solve, I'm going to divide everything by a -1. I think that will make my work a little bit easier. So I'm going to exercise that option and rewrite it in standard form. So positive x squared, negative 74x, positive 840. To solve this, you can use the quadratic formula. Let's write that down just to review it. There it is. So remember that the quadratic formula solves for things that are set to 0. That's its job. I'm going to solve this by factoring because it'll be faster. That's x minus 60 and x minus 14. And you say, wow, how did she know that? I know that because I wrote the question. And so I know what the answers are. But if you want to find it for yourself, I would suggest plug it in the quadratic formula. Those are the two numbers that'll come out. Okay, now the question is, what do those mean on the graph? Well, these are x coordinates where the y coordinate, which is the profit, was equal to 0. That's these 2 points. So that and that. Those are the break-even points. In college algebra, they called them the zeros of the function. However, where we would most like to be on the profit function is not at those 2 points. We'd want to be here. Well, there was a name for that in math. It was called the vertex. And that vertex has 2 coordinates. It has an x coordinate, and it has, in this case, a p coordinate, or we would call it a y coordinate generally. And we want to be able to find that value. Now, there were a couple of ways to do this in college algebra, but the easiest way, the way that will work the best for us to find the vertex. Now, let me emphasize that this is for a quadratic. This technique doesn't work if you have a cubic function. Like, it can't find the high and the low on a cubic function because that's not an x squared kind of function. It only works for parabolas. And you can find the x. The x is equal to negative b over 2a every single time. That x coordinate will be at negative b over 2a. So let's do it for this profit function that I've got. Negative b is 74 over 2 times a is -1. 74 over 2 is 37. Okay, now 37 what? Well, 37 is an x value, so that means units. On the graph, I've found this. That happens at 37. This happened at 14. That was my smaller break-even point. And this happened at 60. So for my vertex, I'll call it V. I now know the first coordinate. The first coordinate is 37. So I know to stop after 37 units. If I go to 40 units, I have lost profit. I've given some money away. What is the maximum possible profit? Well, to find the profit value, I need P. So I'll take this 37, which gives the maximum value, and plug it back into my original profit function. So profit, plug in 37. 74 times 37, take away 37 squared, minus 840, and if you add that all up, you'll get 3,267. That's dollars profit, and that profit only happens when x is at that maximum value, the value that produces the maximum, when x is at 37. Okay, so the vertex is at 37, 32, 60, 7. Okay, so please notice that this is two very different things going on here. Finding the vertex will give you the maximum. Break even is when you set it to 0. So using the quadratic formula, this is what I use if I want to break even. Using this vertex formula is what I use if I want to find the maximum. Here's how I remember the vertex formula. I take the quadratic formula and you take out that square root part. And look, negative b over 2a. There's the vertex formula. Okay, let's bring in a homework problem and practice this. The monthly profit from the sale of a product is given by, and then we are handed a profit function. I didn't have to create it. So you say, thank you, WebAssign, because that's kind. What level of production maximizes the profit? Okay, so I'm looking for the vertex. So again, you're picturing this profit function. You want to be here. I don't want the zeros. I want the vertex. Vertex formula, x is negative b over 2 times a. That's negative b is 12 over 2 times a is negative 0.1. That's negative 12 over negative 0.2, which is 60. That gives me the x coordinate for the vertex point. That is not the value of the profit. That's not $60. That 60 is an x, and x represents the units. So that gives me this first part of the answer. Then for part B, how to find the profit. The dollars is a profit value, which is P. So you want to take profit and plug the 60 back into it. 12 times, plug in a 60, take away 0.1 times 60 squared, take away 200, add that all up. 720 minus 360 minus 200. It's 160. So $160 is the maximum possible profit for this setup. No matter what you do, no matter how many more you make or sell, the best you can do is 160 unless you change the fundamentals of that equation. Let's take a look at another problem. Suppose that in a monopoly market, the demand function for a product is that we have little p, lowercase p, and that in a demand function stands for the price. The revenue function is given by P times X, price times quantity. Form the revenue function. Okay, revenue is price times quantity. For price, we substitute in all of this equation. That would be 120 minus 0.5x times units. X, 120x minus 0.5x squared. So now we see that that is a quadratic function. Second part, find the number of units that must be sold to maximize the revenue. Okay, if we want a max, then don't set this equal to 0. I don't want to know when the revenue is 0. I want to know when it's the best possible. I want the vertex. Vertex is negative b over 2a. Negative b is 120 over 2 times a is negative 0.5. Gives me an answer of 120. Okay, 120 what? This isn't dollars because this isn't an R answer. This is an X. We're solving for X, which is units. Is that what WebAssign wanted? Yes, number of units. Find the price of the product that will maximize the revenue. Okay, now read this carefully. They are not saying find the maximum revenue. They're saying what price should be set to generate that revenue. So I need an equation that will give me price. Well, that's this one. Price is 120 minus 0.5 times any number of units you want to sell. Well, how many do you want to sell? I want to sell 120 because that's the one that works out the best. So this gives me 120 minus 60, 60. 60 what? That's a lowercase p, which is a price. a $60 selling price is the right price to incentivize 120 people to buy your product, and that's the best your revenue can ever be. Okay, so those two concepts, the idea of solving for zeros of a quadratic function, remember that those are these points, or solving for the vertex of a quadratic function, this point. For the zeros, you can use the quadratic formula or factor. For the vertex, you need to use negative b over 2a. It only works if it's a parabola. Okay, let's do this problem. Suppose a company has fixed costs, 36,000, variable cost per unit, pay attention to that, 2/5 x plus 222. X is the total number of units, and a selling price that also is variable. Form the cost function and the revenue function. All right, this is a review of what we've done before. Cost is going to be variable cost plus fixed cost. Your variable cost will be per unit costs, so 2/5 x plus 222 each times x number of items plus, and then put in your fixed costs, 36,000. Distribute the x through, we'll get 2/5 x squared plus 222x plus 36,000. There's my cost function. Revenue is price times quantity. Selling price is this 1452 expression. So 1452 minus 3/5 x, that's just the price. Then you have to multiply that by another x. Distribute that x through, 1452 minus 3/5 x squared. Let's get those filled in. Okay, I got them typed in, and now let me fix some little typos here. That was 222x, and when this x distributed through, I got an x right there. Okay, there's my cost and revenue. Find the break-even points. To break even, you have cost equal to revenue. Cost, 2/5 x squared plus 222x plus 36,000 is equal to revenue, 1452x minus 3/5 x squared. And now I want to solve for that. Since I've got quadratics, I want to set it equal to 0, so I will add the 3/5 x squared to both sides. And then subtract 1452x. That gives me 5/5, which is 1 whole, thank you, x squared. Take away 1230x plus 36,000, set equal to 0. You now put this into the quadratic formula, and you'll get 2 x's from that, 30 and 1200. Okay, moving on. Let's find the vertex of the revenue function. Okay, I've got my revenue function copied now. So to find the vertex, that happens when x is negative b over 2 times a. That's negative 1452 over 2 times a is negative 3/5. Now if you're going to put this into your calculator, you're going to have to put parentheses around that entire denominator. And then when you simplify it, you'll get 1,210. That's the x coordinate, so that's units to maximize revenue. They want the x and the y coordinate, so to get the y coordinate, I take 1210 and I plug that back into the revenue function. 1452 times 1210 minus 3/5, 1210 squared. Calculate that out, 878,460. Okay, identify the maximum revenue. Well, the dollar amount for the revenue is the second coordinate. It's that 878 number. Form the profit function from the cost and revenue functions. Profit is revenue, take away cost. Revenue was 1452x minus 3/5 x squared. Take away parentheses around the cost function. The cost function was 2/5 x squared plus 222x plus 36,000. So 1452x minus 3/5 x squared. Distribute the negative through these parentheses. Negative 222x minus 36,000. Combine like terms, that's negative x squared plus 1,230x minus 36,000. That's our profit function, capital P. Find the vertex of the profit function. The vertex happens at negative b over 2 times a. Now I take the b for the profit function, 1230, over 2 times a for the profit function was negative 1. The vertex is at 615. That's the x-coordinate, which is units. To find the y-coordinate, I take that 615 and I plug it back into the profit function. Negative 615 squared plus 1230 times 615 minus 36,000 gives me 342,225. So the x-coordinate is the units and the y-coordinate is the dollars profit that we can expect. Vertex at 615, comma. Notice that you don't put in the parenthesis because it's already on the outside of the box. 342, 225, and maximum profit 342, 225. Last question, what price will maximize the profit? Okay, which equation out of all of this problem is in charge of price? Where does the price equation happen? Well, it's actually right up here. It's probably the easiest place to find it. There it is. The selling price of the product is, there it is. Price, 1452 minus 3/5 times, put in the x that you want to find the price at, and you want to find the x for the maximum profit, which was this 615. 1452, take away 369, 1,083. That's a $1,083 selling price for each. Okay, so through the rest of the assignment, you've got find the vertex, so maximize the revenue, find the break-even points, which remember that's a different method and strategy than to find a maximum. So one is to set to 0, probably use the quadratic formula. The other one is to use the negative b over 2a. Redo the apartment building that we did from the last section, but this time maximize the revenue. Okay, good luck, and I'll see you next time.